Okay, this problem is a heat transfer problem. So I have a glass thermometer that it's initially at some temperature and I put it into some water and I want to find the final temperature, right? So if we're doing thermodynamic problems, right, where you're looking at heat transfer, the best thing to do is like write out what your variables are first, right? So I'm going to call the ones glass and I'm going to call the twos the water, right? So I'm going to do it this way instead of like doing subscripts for a bunch of things. Okay, so M1 is the mass of the glass, M2 is the mass of the water. And C1, C2, that's the specific heats. And then my initial temperature 1 and my initial temperature 2 are those. So let's fill those in. 300 gram glass, so that's 0.300 back 3 places, 0.3 kilograms, right? Water, 200 cubic centimeters of water is 200 grams. So that's 0.200 kilograms, right? You don't need the extra zeros, whatever. Specific heat of water, because we're in calories, right? Water is 1 calorie, so that's 1 calorie per gram degree Celsius. And glass is 0.2, so I'm going to put 0.2 there. And then my initial temperatures, right? So here's my initial temperature of glass, so that's 25. And my initial temperature of water is 95. So first go through and fill all this in, make a table, right? So now, because we're assuming no heat loss, I can say MC delta T for the glass equals MC delta T for the water, right? M1C1 delta T1 equals M2C2 delta T2. Okay, so M1C1 times my final temperature minus my initial of 1 equals M2C2 times, I'm going to do initial minus final just to get rid of the negative sign. I don't want negatives because one of them is going to be negative like we did in the lab, but because one is losing and one's gaining, right? So I'm going to do initial minus final. So I'm going to do T naught 2 minus TF. And the thing I'm trying to solve for is TF. So I need to combine these terms, right? Okay, and so the rest of this, we're, again, like every other problem, we're basically done. Now it's just algebra time, right? So I have to distribute this in and simplify and get TF together, right? So let's do this. Okay, and here's my final answer. So what I did, I had to first multiply everything in, right? I distributed in the M1C1 and I distributed in the M2C2, right? And then I moved this to the other side to get my TFs together, right? So this term I added because it's being subtracted. And then this term I added to the other side. So basically this one came over here and that one came over here, right? That's where this line is. And then here, now I have my two TFs, so I pulled those out. So it's T final times M1C1 plus M2C2, right? And now I have my TF by itself, so I divide it over to get it. And now, once you're here, now that you made this nice little table, you can come and just plug your numbers in and solve, right? So, I mean, it's easy. It's just a little tedious because you have to write everything out, right? And there's so many variables. But if you make a table and you write everything and do the algebra, now it's just a matter of plugging in what each of these things is, and I can solve for my final temperature. Not that bad.